Hello, welcome to Core User Group 2023. My name is Vineet Gupta. I am Chief Architect at Cloud Signaling Director team. Today I will present SCP for monitoring and mirroring 5G control plane traffic. As a Cloud Signaling Director team, we provide variety of NFs for both 4G and 5G. For 4G, we have diameter routing agent, that is DRA, subscriber location function, that is SLF, and in 5G we primarily provide SCP, which is Service Communication Proxy, then SCPP, which is Security Edge Protection Proxy, and BSF, Binding Support Function. As you can see in the slide that all 5G NFs communicate with each other through SCP. Of course, there are models in which NFs can talk to each other directly, which are called Model A and Model B. But as per 3GPP recommendation, it is recommended to go through Model C and Model D, in which each NF talks to other NF via SCP, which avoids interoperability issues and also reduces the number of connections between NFs. Okay. Since SCP is involved in each communication between all the NFs, this makes it the hub of control signaling in 5G core. Overall, CST SCP has a very high throughput and it has been scaled up to a traffic of 250,000 TPS. The SCP supports both Model C and Model D flows with efficient cache, making it highly performant. But today we are going to focus on the aspect which is tracing and mirroring. So the question comes, why do we need mirroring or monitoring capability at SCP? The main reason is the traditional capture using port mirroring or similar technologies don't work for encrypted traffic. So even if you have the capture, you will not be able to decode the packets as they are encrypted. So SCP terminates the TLS connection, and SCP is involved in all the traffic in 5G core. That's why SCP can send the unencrypted copy of data towards the mirroring server. Okay, and it can be used to capture both ingress and egress HTTP traffic. It also supports Jaeger tracing for tracing application logs and determining the latency, network latency. SCP is fully integrated with Prometheus and Grafana, which gives it ability to monitor performance based on real-time basis. Operator can use CST provided dashboards or have their own dashboards for federation. Before jumping into the demo, I will show how the demo setup is. If you look at the call flow behind me, you will see that we are showing a Model C flow in which consumer and producer are talking to each other via SCP, but there is no service discovery. The important point to note here is, in this setup, we are trying to demonstrate that each and every message which is received by SCP or sent by SCP is being sent to mirroring server. But SCP, as indicated earlier, supports Model D flow also. So this flow is provided for simplicity. Now let's jump to the live demo. On your dashboard, you can see clockwise from the left. First, you see a dial. That dial is giving you the throughput. Right now, we are running a demo, so we are running a low TPS of 4 TPS, but SCP supports 250,000 TPS. Next on the screen, you can see different graphs which are indicating the number of messages which are received by SCP, number of inbound requests, number of outbound requests, and corresponding responses. These next two graphs show that the traffic is being mirrored in both inbound and outbound direction. The next graph shows that Jaeger tracing is also enabled for SCP. Now we have some more graphs like this, which show the distribution of traffic internally within SCP pods. Since we are a containerized environment, the SCP is implemented by SCP pods, and we have n number of them within a CNF. So this is showing the internal distribution. These two dashboards are interesting because these two graphs show the traffic being sent to SCP. Like one graph is showing what data producer is sending, what kind of responses producer is sending to SCP, and what data is being sent from consumer to SCP. So based on this graph, you can see the distribution of traffic to SCP from consumer and what kind of responses are sent by producer. The next screen we are going to show Jaeger tracing. So, SCP has a facility to enable Jaeger tracing based on message filters. Okay, so we can either trace the entire traffic or we can trace a portion of traffic based on message filters and sampling rate. Right now on my screen I show you one sample which captures HTTP request and corresponding response. On top of the screen you can see the progression of processing of the transaction. So, you can see when T0 is the time when the request entered the system, and towards the end we see the time taken for SCP to send the final response. This includes the time spent by SCP for processing request and response, as well as time spent by SCP for waiting for the response. Here you can see the application payload, the HTTP request with the message body. In conclusion, we can see that SCP as a signaling hub provides a facility for mirroring and monitoring traffic on real time basis, giving high observability in 5G core traffic. Thanks for your attention.